Okay, this video is going to be part 2 for the inverse of a relation, and we have one last concept to go through, which we're going to look at in 2 different examples. And then when we're done these 2 examples, that's going to be that will conclude all of the concepts in your unit on transformations. Okay, so what we're going to be looking at now with the inverse of relations is we're going to be looking at something called restricting the domain on a function. So what it says is it says restrict the domain on the function y is equal to f of x. So this is the original function y is equal to f of x so that its inverse is a function. And remember that when we do inverse, we could write inverse in 2 different ways. We could denote it in 2 different ways. So we could say when they're talking about inverses, we know that the x and the y are interchanged. So if you see x is equal to f of y, you know that the transformation is going to be an inverse, or they could write it in function notation, which would be y is equal to f inverse of x. We only will denote it this way though, if the inverse is going to be a function. So what's going to happen with these examples is if I give you this original parabola here, and if I say, is this inverse going to be a function? Right? Is the inverse of this graph going to be a function? You should know now from part 1, just by looking at this parabola, it is not going to be a function, right? The inverse is not going to be a function because if I do the horizontal line test on this parabola, and it doesn't matter where I do it, but I cut a horizontal line or draw a horizontal line through my parabola, it cuts the original function twice, therefore the inverse is not going to be a function. So let's actually just quickly illustrate that. So let's take the vertex here. So the vertex is 3, -2, and the inverse is going to be -2, 3. So -2, 3. Okay, so that's where the vertex will be. And then I'm going to take some points. So let's take this point here, and that point is 5, 2. The inverse is going to be at 2, 5. So 2, 5 would be there. And one last point I'm going to take is I will take this point here. So that point is at 1. So actually, let's draw. So we're going to have this, and we're going to have that pink point was at 1, 2, so 2, 1. That's reflected there. Okay, so this is my inverse, and I hope you could see that the inverse is not a function. Now, what the question is saying is how could we restrict the domain of the original function? How could we restrict the domain of the original function so that the inverse is a function? What I'm going to do is I'm going to erase this. I just want you to see that the inverse is not a function. The vertex is going to act as a key point to do this. So vertex acts as a key point. Okay, so the vertex was 3, -2. What you want to look at on the vertex is you want to look at your x values. And basically that is x is equal to 3, right? So this vertex is x is equal to 3. What I could do is I could say that this piece of my graph, is x is greater than or equal to 3. And this piece of my graph is x is less than or equal to 3. When they talk about restricting the domain, what they want us to do is they want us to restrict the domain of the original graph based on that vertex and the x value. So restrict y is equal to f of x to x is greater than or equal to 3 or x is less than or equal to 3. And here's what I mean. If I say I'm going to restrict my original graph to x is greater than or equal to 3, what that means is I only care about this red graph here. And if I said, okay, we're only going to graph this red piece here, what would the inverse of this red piece be? If I'm just caring right now about this red piece, the inverse of that red piece would be 3 comma negative 2 would be negative 2 comma 3. So negative 2 comma 3 would be there. And then this point, which was 5 comma 2 would be 2 comma 5, which would be right here. If I restricted my domain of the original graph to x is greater than or equal to 3, my new inverse would look like this. I'd only be doing the top half of the parabola. So if I only graphed the right-hand side of my graph, this would be my inverse, and that is now a function, right? Conversely, I'm going to erase this red, and let's do the pink piece of my graph. So this piece here, okay? If I said I'm going to restrict my original graph to x's less than or equal to 3, that would be this piece here. If I only graph the inverse of this piece, what would it look like? So 3 comma negative 2 is going to be negative 2 comma 3, which would be here. And then another point, this point is, what's that point? 1 comma 2 would be 2 comma 1, which would be right here. That would be the reflection of the original graph. If it's restricted to x is less than or equal to 3, if I restrict the domain of the original, then the inverse is going to be a function. This pink line is a function, okay? I don't know if you have this, but if you don't, please write this down. It says we know that the inverse of f of x will not be a function, right? The inverse of f of x will not be a function because that original graph failed the horizontal line test, right? So the original graph was a parabola. It fails a horizontal line test, so the inverse of it was not going to be a function. However, what we could do is we could restrict the domain of the original function. So restrict the domain of y is equal to f of x. And if you do that, then the inverse will be a function. What we had to restrict it to was x is greater than or equal to 3 or x is less than or equal to 3. What you're doing is you're looking at the x coordinate on the vertex, and that's how you're going to restrict it. So let's look at one more example to see if this makes sense. Okay, they give us a graph, and we're going to actually have to do more work for this because they give us the equation of the graph, but we'll deal with that after. So just based on what I told you, let's look at this original function, y is equal to f of x. So this guy is y is equal to f of x. Is the inverse of this going to be a function? So you should be able to right away look at that and say, no, the inverse is not a function. Let's quickly look at why the inverse is not a function. Let's quickly graph it, and then I'm going to erase the graph. So you could just watch up here. So here's the vertex. Actually, this is going to be the important point, so let's write it down. The vertex is 1 comma 3. And that means that the new vertex will be at 3 comma 1, which would be right here, right? If I take this point here, which is at negative 1 comma 7, it's going to be 7 negative 1. And if I take this point here, which is at 3 comma 7, it's going to be 7 comma 3. Okay, so just to quickly show you, there it is. The inverse is not a function. This inverse fails the vertical line test. So how do we make the inverse a function? What we have to do is we have to restrict the domain of the original function. So the domain of the original function, we're going to look at the vertex and we're going to look at the x value on the vertex. X is equal to 1. So we have two different pieces of this graph, right? we have this piece here, and that piece is when x is greater than or equal to 1. And we have this piece here, and that's the piece when x is less than or equal to 1. So how we're going to restrict the domain of the original, we're going to restrict f of x, the domain, to x is less than or equal to 1 or x is greater than or equal to 1, right? And again, this red graph here, if I was to just do the inverse of this, the vertex would be at 3 comma 1, right? And what was that other one? Negative 1 comma 7 is 7 comma negative 1. So that is the inverse of just the original graph when it's restricted to x is less than or equal to 1, and this is a function, right? The pink guy would be, this point is 3 comma 7, so 7 comma 3. Yeah, if I was just to graph the pink point, right, if I was just to restrict the domain to x is greater than or equal to 1, then my new graph would be that, right? And that would be a function. Now, what they want us to do though, is they're making this slightly more complicated, is they're saying, determine 2 ways to restrict the domain of, they give us the equation so that the inverse of it is a function. So what we have to do is we have to figure out what the new equations are. So the original is y is equal to x minus 1 squared plus 3. So let's write the original. Y is equal to x minus 1 squared plus 3. Okay, let's find out the new equation. So the new equations are, for the inverse, we need to interchange x and y. And then we need to solve for y. So subtract 3 from both sides. Y minus 1 close bracket squared. To get rid of that square, you're going to square root this and this. When you square root both sides, this is going to be plus and minus. So then what we're going to be left with is positive or negative x minus 3 is equal to y minus 1. I need to isolate that negative 1, or that y, by adding 1 to both sides. So I'm going to add 1 to both sides. And then what I have is my two equations, which is, so I'll just write it like this first. X minus 3. Okay, so my two equations are y is equal to 1 plus x minus 3, and y is equal to 1 minus the square root of x minus 3. So I want to show you what's going to happen. We write our two equations. Let's go to our graph. Let's clear all of this. Let's put in our original function, which was open bracket x minus 1 close bracket squared plus 3. Okay, when I hit graph, there's the parabola, right? If you want to put in the line y is equal to x, we could do that. So let's put on our mirror line. It's reflected in the line y is equal to x. So now I got that. Now let's just type in one of the equations. So 1 plus the square root of x minus 3. So 1 plus the square root of x minus 3. Okay, let's see what that is. So I hope you could see what we just did is that would have been this pink piece here, right? So if we look, this piece of the original graph, if I restrict the domain to x is greater than or equal to 1, I get this inverse graph, and this inverse is a function, right? So this was this pink, on my sheet, it was this pink one, becomes this guy. So what that means is this is the new equation if we have to restrict the domain. That was the domain if x was greater than or equal to 1, right? So this piece is when x is greater than or equal to 1 becomes this piece on the inverse. So if my equation of my inverse is this, it's because I've restricted the domain on the original. So this is how you would write one of your answers. Then you have to do the other piece, right? So now I'm going to go back to my graph. We're going to graph this one in. So let's go back to y is equal to, and let's change this to a negative. So let's change that to 1 minus, graph it. There's my original. There's my reflection line. This piece here, reflected, becomes this piece over here. So the equation is going to be a function if the domain of the original was restricted to x is less than or equal to 1. So if x is less than or equal to 1 on my original, okay?